welcome back. Hector here from helpmegraduate.com. Now, with the combination of the little tips I gave you on radicals and chain rules and when are radicals supposed to use chain rules when you have a composition of functions, which is almost all the time in radicals. Now we're going to do an exercise, an example, okay, involving radical and something in it. Remember, keep in mind the following. There is the square root, and then the inside you have the argument, okay? The square root is the outer operation, okay? It's the major thing, and then the argument, the inside, is what we call the intern part, the intern function, okay? What is going to be also known as the intern derivative, as you will see, okay? So now we have the example y equals cubic root of x plus 1 divided by x minus 2, all of this squared, okay? And remember the example I told you in the past video where you have to convert radicals into exponents. That is what we're going to do to make this a piece of cake, because otherwise then you may have been thinking something like, whoa, well, derivative of a cubic root, well, that's 1/3 cubic at the bottom, but what do I do with the square? Then I'm going to have a division on front, then what then? Relax, okay? Everything under control. Just take a deep breath and let's rewrite the function as something that is more friendly, okay? So this y is going to be rewritten or rearranged to x plus 1 divided by x minus 2. All of this powered to 2/3. Okay, remember that when you have a rational exponent, the bottom, the denominator, is the degree of the root, and the numerator is the original exponent. Okay, so 2/3. Okay, and now we're going to apply the chain rule, which you have right here, okay, into this function. Okay, where is g? Well, let's ask the function, what are you doing to the variable? I have a variable, it's called x. What are you doing to it? Well, I add 1, then I divide it by x minus 2. So that is the first thing that I do. What do I do next? Well, let's see, I do the square of that, and then I do the cubic root. Oh, that's good. So first thing that you do is x plus 1 divided by x minus 2. So that's going to become g. Okay, this becomes g. Okay? The outer part of the function is going to be the exponent. F is going to be 2/3. So all we're going to do is follow the rule, and that way we will find the derivative of the original exercise. Okay? So y prime is going to be equal to chain rule of this, okay? And how are we going to find the derivative of this? Exactly like an exponent, okay? 2/3 goes down. 2/3 goes down multiplying 2/3. Evaluated in g. What is g? X plus 1 divided by x minus 2. Where we write it, x plus 1 divided by x minus 2. And remember that we're doing the derivative of f, which is an exponent, so 2/3 goes down, and then 2/3 minus 1. 2/3 minus 1 is 2/3 minus 3/3. So that is minus 1/3. Okay? So we have here minus 1/3 times. Now comes intern derivative of g. Okay? We're going to write it down right here. X plus 1 divided by x minus 2 prime. Okay? I haven't calculated the derivative yet. Why? Because it's a division. Okay, we can do it right here on the side on a second, and then we will post the result right here. So let's do that right now, okay? Let's divide this for a second. Let's pause for a second and calculate the intern derivative of g. Okay? So g prime is x minus 2, derivative of a division, square. Okay, let's make it a little bit bigger. Maybe you may not be able to see it right there. X minus 2 square, lower part, upper part, x minus 2 multiplied by x plus 1 derivative minus x minus 2 derivative multiplied by x plus 1. Okay? And now I'm going to do it real quick because by this stage you should already be familiar with this. Okay? Derivative of x plus 1 is 1 because derivative of x is 1 and derivative of 1 is 0. Derivative of x minus 2 is 1 because derivative of x is 1 and derivative of 2 is 0. So I'm going to change that, replace that right here. Okay? Here, I end up with a 1 multiplying, and here I end up with a 1 multiplying as well. Okay? And of course, my minus sign right here. Okay? G prime. So all I have to do is simply, operate this. 1 times this is this, and 1 times this is this. So I'm going to get rid of the 1. Okay, I don't really need it. And just rewrite this. Okay? So this goes away, and this goes away. And I have x minus 2 minus x plus 1. Let's get rid of the parentheses. And let's rewrite that 2 again. X minus 2 minus x plus 1. X minus x, 0, minus 2 plus 1, minus 1. So I end up having minus 1 up here. And the lower part stays the same. So this is G prime. Minus 1 over x minus 2 squared. So now I put this in here, which is the internal derivative. Minus 1 divided by x minus 2 squared. Okay? I can delete this. There we go. So all I have to do is now simplify. Okay? Y prime is equal to, let's see, minus 1 times 2/3 is minus 2/3. Okay? So it's minus 2/3. It multiplies x plus 1 over x minus 2. All of this powered to minus 1/3. Multiplied by 1 over x minus 2 squared. And there you go. That is your solution for the exercise. Is there something else I can do to this to simplify this? Maybe. Do you think so? If you do, leave your comments on the video. And if you're sure that this is the end of the exercise, say it as well, okay? Sometimes I like to throw in those little tricks, curveballs to you, to see if you're in sync with me, okay? Again, let's recapitulate again. Let's do it over again so you can see what happened. Our original function was y equals cube root of x plus 1 divided by x minus 2 squared, okay? What did I do? I have a radical, and according to the past video, I'm just going to rewrite that function and expressing it as an exponent, okay? So this is converted to x plus 1 divided by x minus 2 powered to 2/3, okay? Here's the 2, and here's the 3, okay? And now I apply the chain rule in this exponent function, okay? 2 goes down, 2/3. I decrease the degree of 2/3 by 1. 2/3 minus 1 is minus 1/3. Evaluated in g, x plus 1, x minus 2, which we determined at the beginning, multiplied by the internal derivative of g, which is minus 1 over x minus 2 squared, and we determined that right here. Just simplify, add here and here, a few operations here and there, and we end up with this, which if you want to simplify, if you think you can, if you think that it's worth it, and if you think that it's possible, do it away, okay? I hope you enjoyed this series of video of chain rules and derivative using chain rules, okay? If you have a specific request, a question, just simply send me an email on the website helpmegraduate.com, or just simply comment on the comment section on YouTube, okay? Take care, have fun.